Hey, welcome back. So I've been meaning to do a video on OpenAI's new O1 models for a while now. And actually, if you look at the community, a lot of people have been complaining about the models because they're saying, hang on, it's just doing chain of thought and it's doing chain of thought at inference time. And the GPT-4o models already do that. So what is the point of it? Well, actually, one of the things that I don't think you quite realize is that the O1 models, or the earlier Strawberry versions, are actually what trained the GPT-4o models in the first place. So actually the reason you're getting good chain of thought is because the Strawberry models trained the GPT-4o models to have good chain of thought in the first place. And today I'm going to show you exactly what I mean by that. So to get started, before we look at the O1 models themselves, we're actually going to start with GPT-4o for a second. And I'm going to ask it a very simple question. If you've ever read the Around the World in 80 Days, you know Phileas Fogg was traveling around the world. So I'm going to ask this question. If Phileas Fogg had the entire Harry Potter book series on audiobook, what book would he be on by the time he got to Brindisi? So that is one of the first stops he made in the book. And I'm saying, remember, Phileas will need some sleep. And I'm specifying don't think, don't output steps, just give me the answer. So I don't want thinking time. I don't want it to consume tokens on inference. I just want it to output an answer as quickly as possible. If we run that query for a second, you see it's going to come back with is likely to be on Harry Potter and the Prisoner of Azkaban. In fact, if I ask that question a few times, we'll just open up another window there. It now says Goblet of Fire, and it's been a little bit inconsistent, and then I'll ask it again, Goblet of Fire, and let's ask it one more time, and you see it's on a second book, Harry Potter and the Chamber of Secrets. It's not taking the time to think about the answers. It's just coming up with things probabilistically very, very quickly. Now, again, this isn't unique to GPT-4o. If I ask the same question of Claude, for example, then you can see it's Harry Potter and the Chamber of Secrets. And again, if I come back into GPT-4o, this time I asked the GPT-4o mini model, for example, again, we're going to get a similar answer, in this case, Order of the Phoenix. So it's a little bit inconsistent on its answers because it's not taken time to think about the problem. If we as humans were thinking about this problem and we were breaking it down step by step, we'd start to think about things like how far is it from London to Brindisi? How long was that train journey? How many books are there in the Harry Potter series? What's the length of the audiobooks? And then we do a bit of math to go and calculate that out. So again, if I come back into GPT-4o for a second, but now I ask that same question, and rather than saying don't think, don't output steps, just give me the answer, I'm just going to ask the question straight. And you see it's actually automatically breaking it down step by step. So it says here, let's break it down step by step. I haven't asked it to do that. It's actually figured out for itself that it needs to break it down. And you see here what it's done is journey to Brindisi, departs from London, and it takes about 6 days, arriving on October the 7th. Then it's broken down all the lengths of the Harry Potter audiobook series. It's counted for some sleep, so he'll sleep 6 to 7 hours a day. He'll listen to about 16 hours per day, blah, blah, blah. And then it's calculated that he should be on the Half-Blood Prince, specifically around chapter 15 or 16. So it's a pretty good answer, and that's how we would expect this. And again, if I come back into something like Claude and we create a new chat, and then this time I'm going to remove the don't think. I'm going to say the exact same thing here. And you see Claude has broken it down in the same way. It's doing this step by step. This is kind of chain of thought reasoning in this sense. Now, in this particular question, I don't need to say break it down step by step. It's already automatically doing that. And then again, here it's come back with, in this case, Harry Potter and the Half-Blood Prince. And that's because Claude is got a slightly different calculation. Now, let's watch what happens when we ask the exact same question of the O1 model. So I'm going to select the O1 preview model. Again, I can keep the don't think, don't output steps, but it doesn't really matter. It's still going to do the thinking here. So you see it's doing this calculation, tracking inference, tracking logistics, calculating podcast time. So it's working out all of these steps, and we'll break that down into a second. And this is all happening at inference time. We're not seeing those calculations, but you see at the end of it, by the time you'd be on Harry Potter and the Order of Phoenix, the fifth book in the series. And if we look at this, here's the kind of chain of thought reasoning. Now, OpenAI has openly said that they are not giving the raw chain of thought. And that's probably because they don't want people training their models off their chain of thought. And you see, I'm figuring out this, blah, blah, blah. I'll identify the book. But you can kind of see it's doing the same calculations as we were doing earlier with the chain of thought calculations, and then it eventually comes down with Harry Potter and the Order of the Phoenix. But the key thing that you are kind of seeing there is it is doing this calculation, right? So it's coming back with the answer by the time Phileas Fogg reaches Brindisi, he'd be on Harry Potter and the Order of the Phoenix. But it's done the thought process. It's worked it out. You are just not privy to that thought process. So it's expending these tokens at inference time. And that is really what's going on here. But if I want to break this down even further, then actually I'm going to go to games. Because actually when you look at logic puzzles in games, then it becomes really more obvious what's happening in this chain of thought phase and how different it is. I'm going to show you how GPT plays today in certain games. So I have a little tic-tac-toe environment. And in this case, it's just a simple Python program. It's available on my GitHub. You can download it, play it for yourself. But what you can see is it's going to run a classic heuristics agent. So it's just a sort of standard rules-based agent. And I'm going to place it against GPT-4o. So if we run that for a second, here is the game. So at the moment, X is the LLM, and you see it's got beaten by the heuristics agent there. In fact, as you can see here, pretty consistently, that it's either going to end up being a draw or the heuristics agent is going to continue to win. So GPT-4o is getting beat at tic-tac-toe. Now, this is a really simple game, right? It's a stupidly simple game. But GPT-4o can't really handle it at that speed because it's not had the time to do its chain of thought thinking or reasoning. It's just been asked to come back with the answers really, really quickly. And again, I can sort of prove that for a second. So I'm going to take one of the outputs from this game, and I'm going to paste this into GPT-4o. I'm going to say, you are X, what's your next move? So if we look at this for a second, you see the game board. The game board is 1, 2, 3, 4, 5, 6, 7, 8, 9. So really the ideal position is going to be position 4 for the game board here, because if you don't go in position 4, then you're going to lose the game because O will go there. So as you can see, the game instructions has the instructions for the game. It's played in a 3x3 grid. Player X always goes first. Player to get 3 of their marks in a row wins if all 9 cells are filled, blah, 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 blah. And there's all the game information. Okay, so I'm going to put that to GPT-4o. And again, if it's playing good, then I should get position 4. But let's see what happens. So you see here it said the player X should place their mark in position 9 to win the game. So let's look at that. You see position 9, if it plays X there, it's going to lose the game. It's a kind of a stupid move. And just in case you're thinking, oh, well, Claude is going to be so much better here as well, we can ask the same question. And as you can see here, Claude came back with the same stupid answer as well. So it's same position 9, bottom right corner. And again, its reasoning is completely sort of messed up. But again, if we start a brand new chat, and then this time I say, think this through step by step. So we're going to invoke some chain of thought reasoning here. And again, it's in this case, it's saying position 6. I think this is a better answer in this case with Claude because it's trying to place this here to kind of create a kind of double move here and here, but it hasn't really recognized that O has potentially got a winning move. And let's see how GPT-4o does in this particular case. So I'm going to say the exact same question, and I'm going to say, think this through step by step. Now, again, this is slightly better. So what I want you to see here is if we look at GPT-4o here from a reasoning perspective, what I want you to see is it's now at least working this through. So you notice the difference here is board analysis. Current board is this. Available positions 2, 4, 6, 8, and 9. Ideally 4 is the position that you want. It's going to say check for winning opportunity. You can kind of see there it's checked for the winning opportunity. If I place an X here, it's got winning opportunity. But notice in the step-by-step reasoning, it hasn't realized that it needs to check for positions where it can lose. Again, I could probably go a little bit further in this case. So I can say, analyze this looking for winning moves, blocking moves before giving an answer. Let's see how it does now. So again, now it's came back, current board state, it's worked through this, available positions, step-by-step analysis, check for winning moves, check for blocking moves, so blocking position 4, and then finally it's got here, player X should place their mark in position 4 to win. So you see by using the chain of thought prompting there, I can get it to come back with the right answer, but I need to give it a strategy. I need to give it a plan. I need to tell it to go check for player X's winning move, check for a blocking move. Now, what I would say in this case is if I come back to, and we'll look at O1 in a second here, but if I come back to GPT-4 for a second, and now I ask the same question, analyze this step by step, look at winning moves, look at blocking moves. I want to see how it does. So have a look at this. So this is probably the major difference between original GPT-4 and GPT-4o. In this step-by-step analysis, notice the difference. It's not listing out each individual number. It's giving me the board, but it's not doing the checking for this move, not giving me a list of the numbers. If we look at this one here, it's given the current board state, available positions, and then it's literally saying player X has marks in position 5 and 6. It's working through each position, right? Whereas in GPT-4 original, it hasn't doing that, but in GPT-4o it does, and that's how it gets to that sort of final position. Now, let's see what happens when we run this against O1 preview. So let's do the same thing. This time I'm not going to tell it to do blocking moves and all these things. I'm just going to get it to analyze it on its own. So here, now it's doing thinking. And again, notice what's happening now. Assessing board boards, identifying winning moves, evaluating strategic moves. And then you see your best move is to place an X at position 4 to block O from potentially winning, which we now know is the correct move. This is what we want to do, is do the blocking. But let's look at this thought. It's 15 seconds. Taking a look at tic-tac-toe game state. Let's think it through step by step. Assessing board dynamics. I'm visually mapping the board positioning and identifying X's potential winning or blocking moves. With X marks at position 3 and 5, I'm in examining space. Then it's evaluating the winning paths, and then identifying winning moves, and then evaluating strategic moves. I'm piecing X and O's threat of winning in their next move. X current positions don't clinch a win, but O's 2 marks suggest they win imminently, and therefore it's came back with X. You see what's going on here? It's doing chain of thought, but it's actually really working out the lines, and it's working out each individual item. So being able to identify that right prompt is critical. But even so, the critical part here, it is doing its working. It's doing it step by step. It's listing out the various positions. It's doing its analysis. But of course, when I look at this in O preview, I don't need to say any of this because it just does it automatically. It does the assessing of the board, evaluating the winning paths, identifying the winning moves. But if you think about this for a second, so in order for O1 preview to be as good as it is, it actually needed GPT-4o to be at a good level of chain of thought prompting in itself. It needed to be trained. The major thing that you can kind of see here with O1 preview is it is doing that chain of thought reasoning at inference time. It's doing it deeper than GPT-4o, but when I did give GPT-4o the right prompt, it was able to get it right. So in order for O1 preview to be as good as it is, it's actually needed to train and fine-tune the GPT-4o models to give the right GPT-4o chain of thought output in the first place. And I think that's one of the major innovations. So if we go back, they were talking about the strawberry model back in November last year. I think one of the major things that's happened is the strawberry models have been training the GPT-4 models to become GPT-4o. And part of that training is to have better chain of thought output in order to satisfy the inference at testing. Because if you don't have that good level of output coming from the model in the first place, then you are not going to get good, consistent chain of thought outputs at inference. Now, if I want to bring this a little bit more real, I can pick another game for a second. So in this case, we're going to do a little bit of Sudoku. So I'm going to use O1 preview here, and I'm going to ask, is this a valid Sudoku grid? If we look really closely here for a second, you will see that it's not a valid grid. You you can see that here's line 1, 2, and 3. You see number 3 there, but if I go to line 4, there's another 3 in the same vertical column. So this is definitely not a valid grid. Let's ask O1 Preview what it thinks. So it's going to sit and think about this for a second. And you see the steps. It's validating the grid, monitoring progress, verifying the grid integrity. So it's doing lots of kind of chain of thought thinking. And then there you go. No, the provided Sudoku grid is not valid. There's an error in column 5. And you can see there's the answer. The issue number 3 appears twice in this column, row 3 and row 4. So violating the rule. So it's got it spot on. But again, let's see what happens if I ask GPT-4o. This is a particularly hard grid. I made this purposely hard by doing the vertical columns. Let's see what GPT-4o is. And there you go. So GPT-4o got it wrong. The Sudoku grid is valid since it satisfies these conditions, but it hasn't sort of worked out its steps there. Again, if I do it this way, and I'm going to say, think this through step by step, and we'll say checking rows, columns, and subgrids. Let's see how it does now. You see what's happening now? Now I've asked it to do step by step. So you'll see it will check each row. There are no duplicates. So it's done the check rows. Now it's going to check columns here. And it's literally listing out each column. And there we go. Column 5, 1, 5, 3, 3, 3. Duplicate found. 3 appears twice in this column. And then eventually it does all the subgrids. So it's doing chain of thought reasoning, but I have to give it the right prompt to give the right output. If I just ask it to do it straight without saying step by step, check rows, columns, etc. from a plan, then it doesn't get there on its own. But if I give it the right plan, if I give it the fact that I want to do it step by step, GPT-4o gets there fine. And by the way, if we come back to Claude for a second, so let's start a new chat with Claude. We'll ask it the same thing. I'm not going to ask it to do step by step, but you will see Claude is going to come back with the same answer. It thinks it's valid because it's not worked through the problem. If I do the same thing with Claude, I'm going to say think through step by step, checking rows, columns, and subgrids. And then let's see what Claude does. And again, it's doing a similar sort of thing. It's listing out each of those individual items. And again, but even though I've given Claude the right prompt, same prompt that I did with GPT-4o, it's kind of failed there, right? Because it's not got the right steps. Whereas if we look at these steps here, it's done a really good job of listing this out one by one. Remember, it's been trained in the first place. It's fine-tuned in this kind of fulfilling loop where the right answer is making the model's chain of thoughts better and better and better. So if I just go into a standard model, maybe like something like llama for a second, actually let's do that. If I do a llama run and we open up, let's say llama 3, and I'll open up the 70B model. I just want a slightly bigger model for a second. And if I ask the exact same question here, you're going to see that it's not going to do the same level of chain of thought reasoning. So it's going to go through it step by step, row 1. So there we go. I went through kind of llama 3 there, and it's done some step by step reasoning, but you can kind of see it saying no duplicates, blah, blah, blah. And then it's completely messed it up. It's even things like, I'll check a few of them, right? And it's not enough to check a few of them. You need to check all of the grid. So we've done column 1, column 2, and column 3. But what about kind of column 4, 5, 6 and all that, right? It's just kind of not bothered to do the whole thing. So its chain of thought reasoning is out. So even if I try and do this on inference, the very fact in the first place that the chain of thought reasoning on llama isn't correct sort of gives you a clue. And we saw the same with Claude as well, right? Whereas even on the GPT-4o mini, you see check rows, row 1, row 2, row 3, row 4, check columns, column 1, column 2, column 3, valid, valid, valid. The model has been trained for chain of thought reasoning in the first place. This is my critical point, right? And earlier models of GPT-4 wouldn't have been trained with that. And if I really want to prove my point, rather than looking at GPT-4o or GPT-4 Turbo, let's go to original GPT-4. And I'm going to say, is this a valid Sudoku group? Think through this step by step. And then if we hit run, you can see a valid Sudoku grid should have, blah, 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 rows are valid, check squares, no repetition. See the difference? It thinks it's a valid grid, but even though I've asked to do it step by step, it's not done the whole sort of, here is column 1, column 2, column 3, right? GPT-4 original didn't do that, whereas we did see that with GPT-4 Turbo, and we saw that with GPT-4o, and I would argue GPT-4o was slightly better than GPT-4 Turbo, right? And again, we can do this kind of one more time. So if we clear the chat, this time I'm going to set it to GPT-4 Turbo. Let's do the same thing. See the difference? All unique, all unique, all unique. So you see the difference between GPT-4o, GPT-4 Turbo, and original legacy GPT-4? It's writing it out line by line. Even Llama 3 isn't getting this correct. So back to my original point about what I was saying about O1. It's not the fact that it's just chain of thought happening at inference time, which of course it is. The key thing is that the model GPT-4o and GPT-4 Turbo has been trained to have the correct chain of thought reasoning coming out. And that's been happening for a very long time. Because if we look at original GPT-4, it wasn't outputting in the same fashion that we did there. It didn't have column 1, column 2, column 3, etc. It wasn't having that good step-by-step reasoning. And that's similar with the Llama models. It doesn't have that good step-by-step reasoning. So the real thing that's happened with Orion models is, yes, it's doing that inference time where it's generating the chains of thought, but then it's selecting it similar to that kind of star process that I showed you in one of my other videos, and then it's fine-tuning back into the model. So it's this collective virtuous circle where inference happens and then it gets trained back into the model to generate good chains of thought. So when you're saying, hang on, this is just chain of thought, is there something really special that's going on here? Remember, you're looking at the output of a model that has been trained to output good chain of thought by default. If it's not outputting good chain of thought from the model, then even at inference time, you're not going to generate the right stuff. And it's going to be harder for the inference time calculations to come to the right answer. And that's the real trick of what's going on here. It's this virtuous circle. So to kind of conclude what's going on with O1 Preview, it is an awesome model. I love what they're doing, but the games show exactly what's happening, right? It is generating good chain of thought. It's happening at inference time, or test time, as they like to call that. And then what's happening is the model is working through some sort of tree. It's probably something like a Monte Carlo tree search to be able to check all the different answers, walk the nodes, run multiple chain of thoughts, and then eventually come to the right answer. So you don't need to say things like step by step anymore, but it's more than just whatever the model comes out with in the first place with its chain of thought reason. Yes, it needs the model to come out with the right chain of thought reasoning, which it's been trained to do. But then the model at inference time is able to validate that, even run it multiple times if it needs to, so it can come back with as good of an answer as it possibly can. But if the model hasn't been trained in the first place with the right data, it's clearly been trained on things like sudoku, it's clearly been trained on things like tic-tac-toe, then it's not going to come back with the right answer either. So so when we look at this and say it's just chain of thought, remember you're looking at a model that's been trained by kind of the original Strawberry models for the last year to have the right chain of thought in the first place. So, and again, if you look at something like the Llama models, for example, they're not coming back with the right answers, and GPT-4 is not coming back with the right answers because they haven't been through that loop. At the end of the day, what an absolutely awesome model. I love the technique. I love the fact that it's doing it all at inference time. I love the use of reinforcement learning. And you can see it makes an absolutely huge difference. However, everything is not perfect. So let's just come back into kind of main ChatGPT for one more second. And I'm going to show you where it actually goes wrong as well. So we're going to bring up O1 Preview one more time. And this time I'm going to ask a question that is, the answer is hidden in the question. This is not a cheese you should eat before bed. Am I right? This is really a tokenization problem. So like where they said before, haha, it can now handle the question, how many R's are in strawberry. this is a sort of a nice little logic puzzle. So the answer is hidden in the question. This is not a cheese you should eat before bed. Am I right? There you see the word Edam. So if I ask this question here to O1 preview, it's going to start thinking. It's going to start clarifying its understanding. It's inspecting the statement, combining clues, interpreting, trying to figure out the answer. It tries to work with wordplay, but you see the answer is nacho cheese. It's not learned how to do this, right? So it's not perfect. And that's probably because it's not been trained on that particular style of question. Similarly, I can ask it a different question. So I'm going to say, let's open up a new window. And then this time I'm going to say, we're going to play a game called Elephant in the Room. I stole this from House of Games. The elephant in the room is a word that I'll choose. No matter what question I ask you, you should not say that word in the question, including if the word is a subword of a larger word. So if the elephant in the room is Don, and the question was, which restaurant chain has golden arches as its logo? The answer would be McDonald's, right? So it's getting rid of the Don part. So McDonald's, so it would become McDonald's. So we're going to say the elephant in the room is Star. Who did Robert Downey Jr. play in Iron Man? And the answer should be Tony K. So it's going to start doing its thinking again. It's going to engage in the game. It's going to do some exploration. It's going to think about how to avoid certain words, read carefully. And again, it came back with he played Tony S.K. So it was close. It got the fact it shouldn't say star, but then it included the S. So, nice try, but not good enough. And we can prompt it a bit more. Check. Again. And again, it's had another shot there. Apologies. Let me try again. He portrayed Tony. And again, it's had a go at this, but it's kind of messed it up as well. So why is it not getting that right? And I think it's simple because the chain of thought reasoning in this case is not going to be any good. It's never been trained to play this game. And therefore, but it has been trained to do the count of strawberries, right? So it's going to do a better job, but it's not been trained to play the House of Games Elephant in the Room game. It hasn't been trained to play the word puzzle game that we showed, but it had a pretty good go at it. It tried to work out a plan or reason, kind of checked its answers, did all of that. But in order for these logic puzzle games for it to do well, then it needs to be trained and, go through reinforcement learning, get its rewards, etc., and then generate the correct chains of thoughts. So maybe in a few other turns, it will, a few more versions of the model will be able to get the right answer, but not just now. So coming back to the original point of this video, I love the Orion models. I think they're great. I love inference at test time. I love the fact that it's checking its answers. I love the fact that it's generating its chain of thought always. It's doing validations. It's generating multiple chains of thoughts. It's validating it. It's walking through a tree. It's all brilliant. But, as I said at the beginning, if the base model isn't trained to generate good chains of thought in the first place, it's not going to be able to replicate what's going on. So you could try this with Llama 3. You could try this with the Mistral models. You could try this with original GPT-4 and even the Claude models. But if they're not generating the correct chain of thought, then it's not going to get the right answers in the first place. This is the trick of what's happened with the Orion models, right? The real trick is that from GPT-4 Turbo and GPT-4o onwards, OpenAI for the last year has been training those models to come up with the right chains of thought and building that into the right base models and then going through that iterative loop. And now when you're doing the inference time, it's generating the correct chains of thoughts, and then the inference checks can then double down and do the validation. That is the real innovation that's going on there, but it's built on retraining these models for the last year. So what am I expecting for something like kind of the big kind of GPT-5 style fully native trained ones? I'm expecting this to be like on steroids, right? I'm expecting that all data that's went into those models have been trained with the correct chain of thoughts in the first place natively, rather than necessarily always fine-tuned. I'm expecting more data to come through this, and I think it's going to be a cracker. But anyway, hopefully this video has been useful, and then maybe in a future video we'll talk about how to do things like reinforcement learning. And I'll catch you on the next one.